Our next way of measuring up a rect site will be trilateration. As you may remember from the offsets video, it's not always possible to get to a part of the rect site directly at a right angle from the baseline. So we need to look at other ways to measure up a site. Trilateration is slightly more accurate as well. The more measurements you take to something, the more accurate the position is going to be. So let's get stuck into it. For this, you will need your rect site, you'll need your baselines, look for your trilat recording form, and you will need a tape measure and a pencil again. So let's first look at the trilat recording form. We have several columns here. The first, BL, standing for baseline, and you'll remember from the offset recording form that we named the baselines differently, so that when we go back to plotting our site, we know which baseline we're working from. In our case, we've named this one number 1 and this one number 2. But depending on how you lay your site out and depending on which baseline you decide to number, you can call them A and B, you can call them whatever you want. You may have something different, but you need to remember what they are. What might be helpful is to label them. So I'm going to write 1 and 2 on my set square. Next, we look at the point numbers. And again, we will have marked these on our rect sites, but because this is quite small, it would be difficult to put numbers down. So we would have marked them on our site plan. In our case, these two ends of the cannon were 1 and 2. For trilateration, let's look at a different cannon, and we'll call these point 3 and point 4. But we will get to that in a second. You'll see, in order to do trilateration, we will form a triangle and we will take 2 measurements. The information that we will need to gather is a distance along the baseline, which we'll look at in a second, and distance from that point to the artifact, a second point on the baseline, and the distance to the artifact. Again, are we left or right of the baseline? And then any details or comments, so we remember what we are looking at when we go and plot this later on. So we had this named Canon 1, 2, and 3. So we'll be working with Canon 1 in our case. Again, your numbering and your system of recording may be different. The way that trilateration differs fundamentally from offsets is firstly that we're using 2 points, but also we don't actually need a tape measure as a baseline. Instead of the tape measure, what we're looking at is points along the baseline at distances that we know. You'll see in your manual that there were various ways of marking those points, little tags that we could put on a string baseline, numbered 1, 2, 3, 4, 5, etc. So we have tape measures here because we're using them for offsets, so we can still use those. But instead of looking at the measurements in between, we will just use the centimeters, again starting from 0, 1, 2, 3, 4, 5, and so on. We want to measure 2 points, and we want to make a triangle in order to plot a point there. And you'll see how we do that when we start drawing up the sites. But to give you an idea, when we draw our baseline on a piece of paper, we will have 2 measurements. We can use a compass to go from the baseline and the point that we've selected on the baseline for the distance away from the baseline or to the artifact that we had measured, and we will draw an arc with our compass. From our second point, we will do the same thing. Having the distance, the point on the baseline, we will draw another arc. And where those 2 arcs intersect, as you will see when we draw up the sites, is where that point is. So let's look at that in action, and let's look at filling in our trilat recording form. So let's start at this point of the cannon, and we will call this point number 3, following on from 1 and 2 that we did with offsets. And the other point that we will do is point number 4. So we may as well write that in now as well. The baseline that we're using is baseline number 1. So we record that. And now we need to do things a bit more carefully. As I said, we want to make a triangle between the point and the baseline. We don't want that triangle to be too narrow. We don't want that triangle to be too wide. So this angle here, ideally, we'd like to have between 45 and at the maximum 90 degrees, but that's not always possible. So you don't have to use that as a hard rule, but it's something to try and strive for. So if we do look at an angle that's roughly 45 degrees, we could select our first point on the baseline. We're going to use 8 centimeters. We would measure from the 8 centimeter mark to the object. Again, always measure to the same side of the baseline or the same point on the baseline. So our first marker would be 8 and the distance is 6.5 centimeters. So let's have a look at that. In our case, our markers are the centimeter markers, 1, 2, 3 and upward to 25, and we selected marker 8. So on our form, baseline marker 1 is 8. The distance from baseline marker 1 was 6.5. We've filled in the units as we did before to make sure that we remember what it is that we're working on when we start mapping our site on paper. So we may want to check that. Let's see, 2.8, 6.5 centimeters. So that was correct. We need to get a second point in order to have those two arcs intersect. So we'll select another one further down the baseline. Let's take point 13. So we put our tape measure on the point that we're trying to measure, the same point as we did before, and we look at how far it is to the point on the baseline. Now this is not quite 7 centimeters. I would say 7.7 centimeters. So to marker number 13, 7.7 centimeters. And we will do that from baseline marker 2 was 13, distance from 2, 7.7. Excuse me, I made a mistake there. Left and right of the baseline, looking from 0 up the baseline, this is on the left-hand side. So let's mark that down. Left-hand side. Details or comments. This was the front of cannon number 1. So we'll write front of cannon 1 in our comment section. Let's do the same for the back of the cannon. I'm going to put the tape measure there and look for a marker. In this case, I'm going to take marker number 4, and I see that it is 10.2 centimeters from marker number 4 to the back of the cannon. So this is point 4, the back of the cannon. Marker number 4, the distance was 10.2 centimeters. So we fill that in, distance from 1, 10.2 centimeters. Because I've made a mistake, I've decided to use the next line along, and I've crossed out that line. Making mistakes is absolutely fine, and I'm sure you will make mistakes as well. We've given you a few extra trilateration and offset recording forms because we know that you'll make mistakes. These really are the documents that you're using on your site. This is the raw data that you're collecting. So it doesn't matter if you've made an error, just correct it. Make sure though that whatever you've done is clearly crossed out and that the rest of the information is logical and clear for the person who's going to be mapping the site. So we need a second point for the back of the cannon. We put our 0 on the cannon. Let's look at point 12, which is 10.1 centimeters from the baseline. Again, I'm using the inside of the baseline in this case. So 10.1 centimeters from marker 12 on the baseline. So let's fill that in. Baseline marker 2 was 12. The distance was 10.1 centimeters. It was on the left-hand side of the baseline, and this was to the back of cannon 1. So that's how we would use trilateration to measure up elements on the rec site. Now, you will decide which parts you think are best suited to offsets and which parts you think are best suited to trilateration. I would imagine that these objects over here are quite well suited to offsets. You can see them, they're close to the baseline. Perhaps that anchor over there as well from baseline 1. These ones, this anchor may be a bit more difficult. And you'll remember that I said there are problems of how to deal with objects that are in the way or objects that are higher than the baselines are. And you'll remember that I said when there was an angle between the baseline and an object, that measurement was not the actual measurement. That measurement is longer than the horizontal measurement. So we want to try and keep things as horizontal as possible. And there's several ways that we can do that. The best way, I believe, is to raise up your measuring tape. You would need, and you may need help to do this, ask your friends if you do need help. Let's say we're doing offsets and we want to look at that piece, that end of the cannon over there from baseline number 1. So we put our 0 as best we can. Using a pencil or a ruler, we set the 0, and using a pencil or a ruler on the other side, we will look at the distance measurement in a way that is as horizontal as possible. As I said, you will probably need a friend to do this unless you have 3 hands, but it'll give you much more accurate measurements. So keep the tape measures as horizontal as possible and make sure that the distances that you're measuring are the shortest distances if you're doing the offset, and are the shortest distances on the horizontal level.